Alright, let's go. Number 10, HD 189733b, the Glass Rain Hell World. In 2005, astronomer Francois Bouchy discovered something extraordinary, orbiting a star 63 light-years away in the constellation Vulpecula. Using the transit method, his team detected a planet slightly larger than Jupiter locked in a death spiral around its parent star. What makes HD 189733b truly remarkable is its color. When astronomers turned the Hubble Space Telescope toward this distant world in 2013, they found something hauntingly beautiful. A deep cobalt blue planet, reminiscent of Earth from space. But this similarity is where all comparisons to our world end. HD 189733b orbits just 4.5 million kilometers from its star, 13 times closer than Mercury is to our sun. The tidal forces have locked one face perpetually toward the stellar furnace, creating a dayside that reaches 930 degrees Celsius, hot enough to vaporize zinc and lead. But temperature is just the beginning of this world's horrors. The atmosphere screams with winds reaching 8,700 kilometers per hour, approximately 7 times the speed of sound on Earth. These aren't gentle breezes, but hypersonic shockwaves that circle the planet in continuous, violent circulation. What makes HD 189733b particularly terrifying is the source of its beautiful blue color. Unlike Earth's sky, which gets its hue from Rayleigh's scattering of sunlight by air molecules, this planet's color comes from silicate particles suspended in its upper atmosphere. On the day side, temperatures vaporize sand and rock into microscopic glass droplets. These particles are then caught by those devastating winds and blown to the cooler night side, where they condense and fall as rain. But this isn't rain falling gently downward. The glass shards are accelerated sideways at Mach 7, creating horizontal storms of molten silica that would shred any material we know. The planet's beauty is deceptive, a siren call of cobalt blue, masking an environment of unimaginable violence. If we could somehow survive the crushing atmospheric pressure and searing heat, we'd face an atmosphere filled with microscopic glass moving faster than bullets, driven by winds that would tear apart any spacecraft humanity could build. It's a reminder that in the universe, the most beautiful things can be the most deadly. Number 9, WISE J08550714, the Frozen Ghost World. On a March evening in 2014, astronomer Kevin Luhman was analyzing archival data from NASA's WISE Infrared Space Telescope when he noticed something that shouldn't be there. A faint infrared signature, barely detectable, moving against the background stars. Follow-up observations using the Gemini North Telescope in Hawaii confirmed what seemed impossible, a world drifting through space just 7.2 light-years from Earth, making it the 4th closest known system to our sun. Yet until 2014, we had no idea it existed. WISE J08550714 is what astronomers call a sub-brown dwarf, an object with perhaps 3 to 5 times Jupiter's mass, but not massive enough to sustain even deuterium fusion. With a surface temperature between -48 and -13 degrees Celsius, it's the coldest object ever detected outside our solar system. Unlike the thousands of exoplanets discovered orbiting distant stars, this world has no sun. It wanders alone through the interstellar void, a cosmic orphan ejected from its birth system millions or billions of years ago, now drifting through absolute darkness. What makes this frozen wanderer particularly unsettling is what it represents. In 2016, astronomers managed to obtain a spectrum of WISE 0855 despite its extreme faintness, revealing something unprecedented, evidence of water ice clouds in its atmosphere. This rogue world is cold enough to have weather patterns with frozen water, the first confirmed water clouds detected beyond our solar system. Somewhere in the darkness, less than 8 light-years away, clouds of ice crystals drift through an atmosphere that has never seen sunlight, driven by winds powered only by the world's residual internal heat. The existence of WISE 0855 forces us to confront an uncomfortable reality about our cosmic neighborhood. This dark world drifted past us invisibly for eons, its presence unknown, until the right infrared survey finally detected its faint heat signature. Astronomers estimate there could be billions of similar rogue planets wandering our galaxy, ejected from their solar systems during the chaotic early stages of planetary formation. These ghost worlds drift between the stars, invisible except for the faint infrared glow of their cooling cores. WISE 0855 is close enough that we finally detected it, but how many others have passed even nearer without our knowledge? Silent and dark, their frozen surfaces harboring secrets we may never uncover. Number 8, SGR 180620, the Extinction Engine. On December 27, 2004, at precisely 21:30:26 UTC, Similarly, something extraordinary happened 50,000 light-years away in the constellation Sagittarius. A neutron star no larger than Manhattan unleashed a burst of energy so powerful that it temporarily overwhelmed every gamma-ray detector in the solar system. Within a fraction of a second, SGR 180620 released approximately 10 to the 46 joules of energy, more than our sun produces in 150,000 years. The blast was so intense that it ionized Earth's upper atmosphere from halfway across the galaxy, disrupting radio communications and causing satellites to temporarily malfunction. It remains the brightest event ever detected from beyond our solar system. SGR 180620 is what astronomers call a magnetar, a type of neutron star with a magnetic field strength of 10 to the 15th Gauss, the most powerful magnetic field known in the universe. To put this in perspective, a magnetar's magnetic field is strong enough to fatally distort the electron clouds of atoms from 1,000 kilometers away. These stellar remnants form when massive stars collapse, compressing a mass greater than our sun into a sphere just 20 kilometers across. The density is so extreme that a teaspoon of neutron star matter would weigh 4 billion tons on Earth. What makes magnetars particularly terrifying is their unpredictability. The December 2004 giant flare occurred without warning, a consequence of what scientists call a starquake. The immense magnetic stresses caused the neutron star's crystalline crust to suddenly crack and shift, releasing stored magnetic energy in a catastrophic explosion. We cannot predict when these events will occur, and astronomers estimate there are roughly 30 magnetars in our galaxy alone. The physics are straightforward, but the implications are chilling. If SGR 180620 had been located just 10 light-years from Earth instead of 50,000, the radiation burst would have stripped away our ozone layer within seconds, exposing all life to lethal solar ultraviolet radiation. Mass extinction would have followed within months. Several known magnetars exist within 100 light-years of our solar system. We have no way to predict their outbursts, no defense against their fury. They are cosmic time bombs, scattered throughout the galaxy, each one capable of sterilizing entire planetary systems without warning. Number 7. The Fermi Bubbles, Galactic Eruption Scars. In November 2010, astrophysicist Doug Finkbeiner was analyzing data from NASA's Fermi Gamma Ray Space Telescope when he discovered something that shouldn't exist. Extending above and below the center of our Milky Way galaxy were two enormous structures, each reaching approximately 25,000 light-years into space, together spanning a distance equal to half the galaxy's diameter. These bubbles emit high-energy gamma radiation and had remained completely hidden from view, despite being among the largest structures in our galaxy. The discovery was shocking, not just for the bubbles' immense size, but because they revealed that our home galaxy had experienced a violent cataclysm in the relatively recent past. The Fermi bubbles have remarkably sharp edges, suggesting they were created by a single dramatic event rather than a gradual process. Astronomers analyzing the bubbles' expansion velocity and size estimate they formed between 2 and 4 million years ago, when something at the galactic center released approximately 10 to the 55th ergs of energy, equivalent to 100,000 supernova explosions. The leading theory suggests Sagittarius A star, the supermassive black hole at our galaxy's heart, underwent a massive feeding event, devouring an enormous amount of matter and ejecting powerful jets of radiation and particles perpendicular to the galactic plane. What makes the Fermi bubbles particularly unsettling is what they represent for any civilizations that might have existed near the galactic center during that eruption. The radiation released would have been catastrophic, sterilizing planets across thousands of light years. The event would have been visible as a blinding gamma-ray beacon, announcing our galaxy's violence to observers across the universe. And this was not an isolated incident. Subsequent observations by the Arecibo X-ray telescope in 2019 revealed even larger structures, extending up to 45,000 light-years from the galactic center, suggesting multiple eruption events or a single event far more powerful than initially estimated. The existence of these bubbles challenges our perception of the Milky Way as a stable, peaceful galaxy. We live in a cosmic ecosystem that experiences periodic violent outbursts, eruptions powerful enough to affect the entire galactic structure. Sagittarius A star currently appears quiet, but the Fermi bubbles prove it wasn't always so. The terrifying question isn't whether such an eruption could happen again, but when, and whether any developing civilizations near the galactic core would receive warning before the radiation wave arrived. Number 6, NGC 1277, the black hole that devoured its galaxy. On November 28, 2012, astronomer Remco van den Bosch and his team at the Max Planck Institute published a discovery in Nature that challenged everything scientists thought they understood about how galaxies evolve. Using the Hobby Eberly telescope in Texas, they had measured the mass of the supermassive black hole at the center of NGC 1277, a seemingly ordinary lenticular galaxy located 220 million light-years away in the Perseus constellation. What they found was impossible. The black hole contained 17 billion times the mass of our Sun, comprising 14% of the galaxy's total stellar mass. In a typical galaxy, the central black hole accounts for just 1/10 of 1%. The relationship between galaxies and their central black holes is one of astronomy's fundamental scaling laws. Galaxies and black holes are thought to co-evolve through a delicate feedback process, where the black hole's growth is regulated by the very matter it consumes. When a black hole feeds too aggressively, the energy released pushes away nearby gas, starving the black hole and limiting its growth. This self-regulating mechanism should prevent black holes from growing disproportionately large. NGC 1277 violates this fundamental principle so drastically that it forces us to question whether our understanding of galactic evolution is fundamentally incomplete. What makes NGC 1277 particularly disturbing is what its existence implies. Even accounting for measurement uncertainties, subsequent studies confirming a revised mass estimate of 5 to 12 billion solar masses, the black hole remains at least 40 times more massive than it should be for a galaxy of this size. Something catastrophic happened during this galaxy's formation. Either the black hole formed through a mechanism entirely different from standard models, perhaps through direct collapse of massive gas clouds in the early universe, or it grew by feeding at rates that should be physically impossible, continuously exceeding the Eddington limit that normally constrains black hole growth. The galaxy itself appears strangely dormant, with old stars and little recent star formation, as if the oversized black hole has already consumed everything it could reach, and now sits quietly at the center of its depleted host. NGC 1277 is a cosmic crime scene, evidence of a feeding frenzy so extreme it defies the laws we thought governed how cosmic structures form. What other violations of these fundamental principles might be hidden in galaxies we haven't examined closely enough? Number 5. PSRJ 05376910, the glitching nightmare. In 1971, astronomers at the Molonglo Observatory in Australia detected a pulsar in the Large Magellanic Cloud, a small satellite galaxy orbiting the Milky Way approximately 163,000 light-years from Earth. PSRJ 05376910 appeared unremarkable at first, a neutron star spinning at 62 rotations per second, its lighthouse-like beam of radiation sweeping across Earth with metronomic precision. But as observations continued through the 1990s and into the 2000s, scientists discovered something deeply unsettling about this stellar remnant. Approximately every 100 days, without warning, the pulsar suddenly spins faster. These events, called glitches, violate our intuitive understanding of how rotating objects behave. When a figure skater pulls in their arms, they spin faster due to conservation of angular momentum. But pulsars should only spin down over time as they lose rotational energy through magnetic braking. PSRJ 05376910 does the opposite. In a fraction of a second, its rotation period decreases by about 1 to 2 parts per million, meaning the neutron star instantaneously accelerates to a higher spin rate. No external force acts upon it. No companion star transfers angular momentum. The acceleration comes from within the neutron star itself, through a mechanism that reveals physics operating under conditions we can barely comprehend. The leading explanation involves quantum superfluids existing at scales larger than anything we can create in laboratories. Scientists theorize the neutron star's interior contains superfluid neutrons, matter that flows without friction, rotating via quantized vortices like microscopic tornadoes. As the solid crust gradually slows from magnetic braking, the superfluid interior maintains its faster rotation. Eventually, the stress becomes too great, and the vortices suddenly unpin from the crust, transferring angular momentum outward and causing the observed spin-up. This would make PSRJ 05376910 a 20-kilometer wide laboratory for studying quantum mechanics at macroscopic scales, a window into physics that cannot be replicated on Earth. What makes this phenomenon particularly unnerving is its unpredictability. Despite decades of observations and over 200 detected glitches, scientists cannot forecast when the next one will occur. The glitches follow a statistical average but show no discernible pattern. The neutron star operates according to rules we're still trying to understand, exhibiting behavior that suggests exotic states of matter, nuclear pasta phases, and superfluid dynamics that push the boundaries boundaries of known physics. PSR J0537-6910 reminds us that even in objects we've observed for 50 years, fundamental mysteries remain, and the universe still operates according to principles that challenge our most sophisticated theories. Number 4, SDSS J0100+2802, the impossible quasar. In February 2015, astronomer Xuebing Wu and his team at Peking University announced a discovery that shouldn't exist. Using data from the Sloan Digital Sky Survey and follow-up observations from the Lijiang telescope in China, they had identified a quasar located 12.8 billion light-years from Earth. The light reaching our telescopes had traveled for so long that we observed this object as it appeared just 900 million years after the Big Bang, when the universe was only 6% of its current age. At its center sits a supermassive black hole containing 12 billion times the mass of our Sun, shining with the luminosity of 420 trillion suns as it devours surrounding matter at a staggering rate. The problem is simple and profound. This black hole cannot exist. The mathematics of black hole growth are well understood. Black holes grow by accreting matter, but this process has a natural speed limit called the Eddington limit. As matter spirals into a black hole, friction heats it to millions of degrees, causing it to radiate enormous amounts of energy. This radiation pressure pushes against infalling material, creating a self-regulating feedback mechanism that limits how quickly a black hole can feed. Even under ideal conditions, feeding continuously at this maximum rate since the moment of the Big Bang, a black hole should only reach approximately 100 million solar masses by the time we observe SDSS J0100+2802. The observed black hole is more than 100 times too massive. What makes this discovery particularly unsettling is what it implies about the early universe. For this black hole to exist, one of our fundamental assumptions must be wrong. Either black holes can somehow feed at super Eddington rates far exceeding theoretical limits, or they formed from massive seeds much larger than standard stellar black holes. Some scientists theorize that in the early universe, massive gas clouds could have directly collapsed into black holes of 10,000 to 100,000 solar masses, bypassing normal star formation entirely. Others suggest unknown physics allows sustained super Eddington accretion under conditions we cannot recreate or fully model. The implications extend beyond this single object. Since 2015, astronomers have discovered several other massive early quasars, each one a cosmic impossibility that challenges our models. These black holes formed and grew to stupendous masses during a period cosmologists call the Cosmic Dark Ages, an epoch so early that the first stars had barely ignited. Something fundamental about black hole formation eludes our understanding. Are we witnessing evidence of primordial black holes from the Big Bang itself, or does the early universe harbor formation mechanisms entirely absent from the cosmos today? Number 3, the cold spot, the universe's scar. In 2004, astronomers analyzing data from NASA's Wilkinson Microwave Anisotropy probe noticed something wrong with the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space. In a region of sky toward the constellation Eridanus, approximately 10 degrees across, the temperature of this primordial radiation measured about 70 microkelvin colder than the surrounding area. This might sound insignificant, but the cosmic microwave background is one of the most uniform things in nature, varying by only tiny fractions across the entire observable universe. The cold spot, as it became known, represents a temperature deviation so large that standard cosmological theory predicts it should occur with a probability of less than 1 in 50. When the European Space Agency's Planck satellite confirmed the anomaly in 2013, with even higher precision, astronomers were forced to confront an unsettling reality. There is a vast scar in the fabric of space-time itself, and we don't know what caused it. The cold spot spans approximately 1.8 billion light-years, making it one of the largest structures ever detected. In 2015, astronomers discovered a supervoid in the same direction, a region of space containing far fewer galaxies than average. As light from the cosmic microwave background passes through this underdense region, it loses a small amount of energy through an effect called the integrated Sachs-Wolf effect, potentially explaining part of the temperature deficit. But calculations reveal a problem. The supervoid can account for only about 10 microkelvin of the observed 70 microkelvin temperature drop. Something else must be responsible for the majority of the anomaly. What makes the cold spot truly disturbing are the alternative explanations. Some scientists theorize it could represent a cosmic texture, a topological defect in space-time formed during phase transitions in the extremely early universe, similar to cracks that form in ice as water freezes. Others have proposed more exotic possibilities. In a controversial hypothesis, cosmologist Laura Mersini-Houghton suggested the cold spot could be evidence of a collision between our universe and a neighboring bubble universe in the first moments after the Big Bang, a scar left by an impact with another cosmos. While this remains a minority view, the fact that respected scientists seriously consider such possibilities reveals the depth of the mystery. The cold spot represents a challenge to our most fundamental cosmological assumptions. The cosmic microwave background should follow a Gaussian distribution of temperature fluctuations, a consequence of quantum fluctuations in the infant universe amplified by cosmic inflation. The cold spot's size and intensity violate these statistical expectations. Either we are witnessing an extraordinarily improbable random fluctuation, an outlier at the extreme tail of possibility, or something about our understanding of the early universe is incomplete. The cold spot is a permanent reminder, etched into the oldest light in existence, that the universe may be stranger and more violent in its fundamental structure than our theories predict. Number 2, the KBC Void, our cosmic isolation. In 2013, astronomers Ryan Keenan, Amy Barger, and Lennox Cowie at the University of Hawaii published a paper that challenged one of cosmology's most fundamental assumptions. By analyzing galaxy distribution data from multiple surveys, they discovered something unsettling about our cosmic address. Earth, the solar system, and the entire Milky Way galaxy sit near the center of an enormous underdense region of space, approximately 2 billion light-years across. Named the KBC Void after its discoverers, this vast region contains about 20% fewer galaxies than the cosmic average. We are living inside one of the largest voids ever discovered, occupying a position that appears to violate the Copernican principle, the assumption that we don't inhabit a special or privileged location in the universe. The implications of this discovery extend far beyond cosmic geography. For decades, astronomers have been troubled by what's called the Hubble tension, a discrepancy between two different methods of measuring the universe's expansion rate. Observations of the local universe using supernova and Cepheid variable stars consistently yield a value of approximately 73 kilometers per second per megaparsec. But measurements derived from the cosmic microwave background, the afterglow of the Big Bang, predict a value of about 67 kilometers per second per megaparsec. This 9% disagreement has reached statistical significance exceeding 5 sigma, meaning the probability of it being a random fluctuation is vanishingly small. Being inside a vast cosmic void could partially explain this discrepancy. In an underdense region, local expansion measurements would be systematically biased toward higher values, potentially accounting for some of the observed tension. What makes our location in the KBC Void particularly disturbing is what it suggests about our observations of the universe. If we're observing from inside a cosmic desert, our measurements of fundamental cosmological parameters might be skewed by our special location. The void is large enough that its effects could contaminate observations extending billions of light years in all directions. Astronomers have spent a century working under the assumption that our perspective on the universe is typical, that observations made from Earth accurately represent cosmic averages. The KBC Void suggests this assumption may be wrong. We're not observing the universe from a representative location, but from inside a vast bubble of emptiness that distorts our view. The discovery raises profound questions about cosmic variance and the reliability of our cosmological measurements. How many other observations might be affected by our position? Could the void explain other cosmological anomalies beyond the Hubble tension? And perhaps most unsettling, is our location in this void merely coincidence, or does it indicate something deeper about the conditions necessary for observers like us to exist? An anthropic selection effect that places conscious beings preferentially in underdense regions? The KBC Void reminds us that even our position in space, something we took for granted as ordinary, may be extraordinarily unusual. Number 1, the Boötes Void, the Great Nothing. In 1981, astronomers Robert Kirshner, Augustus Umler Jr., Paul Schechter, and Stephen Scheckman were conducting a redshift survey to map the three-dimensional structure of the universe when they discovered something that shouldn't exist. In the direction of the constellation Boötes, approximately 700 million light-years from Earth, their data revealed an enormous spherical region of space that was almost completely empty. Subsequent surveys confirmed the finding and revealed its true scale. The Boötes Void, also called the Great Nothing, spans approximately 330 million light-years in diameter. In a region where astronomers would expect to find roughly 2,000 galaxies, based on the average cosmic density, they found only 60. It is nearly perfectly spherical and profoundly empty, containing about 10% of the matter that should be there. The existence of the Boötes Void challenges our understanding of cosmic structure formation. The universe is not uniformly distributed, but has a foam-like structure, with galaxies clustered along filaments and walls surrounding vast empty regions called voids. This cosmic cosmic web formed over billions of years as gravity amplified tiny density fluctuations from the early universe, pulling matter from underdense regions into overdense ones. But the Boötes Void is not a typical void. Its extreme emptiness and near-perfect spherical shape are difficult to reconcile with standard structure formation models. Computer simulations of cosmic evolution struggle to produce voids this large and this empty within the 13.8 billion year age of the universe. Some calculations suggest that forming such an extreme underdensity would require more time than has elapsed since the Big Bang. What makes the Boötes Void truly existentially unsettling is imagining what the universe would look like from its center. If our galaxy were located at the heart of this cosmic desert, our telescopes would detect almost nothing. The nearest galaxies would be hundreds of millions of light years away, appearing as faint smudges even through our most powerful instruments. The night sky would contain only the stars of our own galaxy, with the vast darkness beyond offering no evidence that anything else existed. Without the ability to detect other galaxies, we would have no way to measure cosmic expansion, no way to discover the Big Bang, no way to understand our place in the larger cosmos. We would perceive ourselves as alone in an otherwise empty universe, isolated in an island of light surrounded by infinite darkness. The Boötes Void represents cosmic emptiness on a scale that challenges human comprehension. It is a region where the universe has failed, a place where matter has been evacuated so thoroughly that it exists as almost pure vacuum on galactic scales. The Void's existence raises questions about the nature of cosmic structure that remain unanswered 4 decades after its discovery. What process could create such extreme underdensity? Are there even larger voids waiting to be discovered in the uncharted regions of deep space? And what might exist in such perfect emptiness in a region of space so devoid of matter that even dark matter seems to have abandoned it? The Boötes Void stands as the universe's most profound absence, a monument to cosmic emptiness that dwarfs our largest structures, and reminds us that in the grand architecture of existence, nothing can be just as powerful and mysterious as something.